Welcome back, friends. We are going to continue with our topic of states of matter, and today we are going to continue with the liquid state. We have already discussed there are some of the few aspects, and this is just like a repetition before we are going to start discussing about the components of a solution. Now we are saying that a solution can be prepared in one of the following ways. First is by mixing a solid solute or solvent. By mixing a solid and a solvent. That means we are taking a solid, maybe a salt, then we are mixing a solvent, and more especially here we are talking of water. And for example, here is salt and water, so it is salty solution. And then a solution can be prepared even by mixing two different liquids. That is, for example, ethanol and water to form aqueous solution. And that's why we will study something called the components. Two-component solution. That means we have made the solution by mixing the two liquids. Now, what we are saying is that the two component of liquid system, in the two components of liquid system, that means this is the solution composed of two liquids. A solution composed of two liquids, for example, if we are mixing maybe ethanol and water, a solution is composed of two liquids. And such kind of solution can either be completely miscible, can be partially miscible, or immiscible liquids. We already discussed this, but this is just like a repetition. Now, we are saying that a completely immiscible liquid are the homogeneous liquids in which their components tend to mix completely, so that there is no formation of layers between the liquids. And we said that this is because the intermolecular forces in the liquids, they are approximately equal. Thus, the intermolecular force of attraction in the liquids is equal to the intermolecular force of attraction in the solution. And then the second type is the partial or partially miscible liquids. They are homogeneous liquids in which their components tend to mix slightly. So the components of partially miscible liquids, they are mixing slightly, but not completely, as how it is in the miscible liquids. And immiscible liquids are homogeneous liquids in which their components do not mix at all, so that they form layers between the two liquids in the solution. And these immiscible liquids, it is because of the difference in the intermolecular force of attraction between the molecules. So one thing you need to know is that the difference in the intermolecular force of attraction, or the similarity in the intermolecular force of attraction, is the major factor which determine the extent of mixing of these components. So from there, we are saying that liquids are of two types. We have the volatile and the non-volatile. When we are talking of a volatile liquid is the liquid which can vaporize easier. So they are liquids with high vapor pressure and a low boiling point. We already discussed the concept of vapor pressure in gases, but we discuss also here, because when we are heating liquid, the molecules of the liquid, they tend to escape and they form vapor. So the pressure exerted by that vapor is what you call the vapor pressure. Kwa kama tunachemsha maji kwenye sufuria, tukawa ile sufuria tumeifunika, pale kuna vapor, na ndio maana ukifunua tu mfuniko au kama unapikia pressure cooker unakuta kuna vapor fulani inatoka juu, na inatoka kwa pressure. That is because we have the vapor pressure ambayo imetokana na accumulation of molecules ambazo zimetokana na evaporation ya liquid. So volatile liquids, they have higher vapor pressure and low boiling point. That means ukiboil tu kidogo inakuwa na vapor nyingi. Lakini non-volatile liquids are liquids with low vapor pressure and high boiling point. So non-volatile does not mean that they do not evaporate. They evaporate, but at very high temperature. For example, if we have petrol and water, petroli ukifungua tu ina evaporate yenyewe, so we can name petrol as the volatile liquid, while water we can name as non-volatile. Kwa sababu gani? Sio kwamba iweze ka evaporate at room temperature, evaporate, lakini ukiheat ina evaporate. Kwa na tunaona mara nyingi tu water ina evaporate, but water can be regarded as non-volatile because petrol hata at room temperature ina evaporate, while water does not evaporate. Now let's go to the concept of vapor pressure. What we are saying that vapor pressure of a substance is the pressure exerted by a volatile component of a substance formed over the surface at a given temperature. So if the pressure exerted by a volatile component of a substance or a volatile component of solution formed over the surface at given temperature. So now let's go to discuss this in detail, because we will deal with it in our discussion. So vapor pressure of a liquid is the pressure exerted by the volatile component of liquid formed over its surface at a given temperature. Pressure exerted by volatile component of liquid formed over its surface at a given temperature. So as we heat, kama nilivyosema, tukiwa tuna heat water, tunakuwa tuna vapor pale juu, and that vapor tend to exert a certain pressure. That partial pressure of vapor, we call it the vapor pressure. So every liquid at a certain temperature has its own vapor pressure. The vapor pressure is just the pressure exerted by vapor above the corresponding liquid at a given temperature. So simply ni hivyo, ni pressure ambayo inakuwa exerted by nini? By ile vapor. Kwamba ile vapor ina pressure ngapi? Ile vapor ina pressure ngapi? So when the temperature is increased, the number of vapor particles and their velocity also increase, and eventually the vapor pressure is said to increase with an increase in temperature. Kwa vapor pressure always ina increase with the temperature. Kwa nini? Sababu nikuambia kwamba vapor pressure inasababishwa na nini? Number of particles present above the liquid. If vapor pressure, it is due to the number of particles present above the liquid. Now at the same time, remember nimekuambia kwamba unavyozidi kuhiti, number of particles ina increase. That means at the number of particles increase, at the end of the day we'll end up with the solution having the higher vapor pressure. Kwa sababu gani? To increase the number of particles. Inatujua kwamba pressure is direct proportional to the number of moles. Now the vapor pressure of a substance or liquid is temperature dependent. This is very important to understand. It is temperature dependent. Now let's see vapor pressure is saturated vapor pressure. Tuangalie concept ya saturated vapor pressure. Saturated vapor pressure ni kitu gani? When a liquid is tapped in a closed container, liquid particles or molecules will appear to escape to the upper part of the container above the surface of liquid at the vapor at a given temperature. Kwa kama tukiwa tuna heat liquid fulani, liquid particles zitakuwa zinaenda juu kama nini? Kama vapor, zina evaporate. Hasa in a closed container, manake kama tumefunga ile container, zile particles zitakaa pale juu, hazitatoka nje, zitakaa pale juu kwenye ile space. Now the vapor will collide with the wall of the upper part of the container, and kwa hiyo vapor itakuwa inafanya collision, particles of vapor zitakuwa zinafanya collision na ile wall ya upper part of the container, and where it will condense to liquid again, reversible process of evaporation. Kwa inaweza ika evaporate na ikisha evaporate inafanya collision. Inafanya collision. Hii lid ni kama mfuniko la juu. Kwa kama kuna upper part ya container ambayo iko juu ya liquid na mfuniko, collision ndio inakuwa inatokea kule, na baadaye ina uwezo kucondense kule kwenye mfuniko, ikaanza kudondoka tena. Nadhani kama mtu umeshawahi pika labda maharage nyumbani, unaweza kawa unazijua hizi phenomena. Kwa ukipika maharage kama maji yako kidogo, unapochemsha ile maharage unakuta, au mboga yoyote, either maharage, nyama, mboga yoyote, kwa water, ni kweli maharage sio solution, lakini because there is water ina evaporate na kuja juu. But later ukifunua ile mfuniko unakuta nini? Kuna drops kule chini ya mfuniko. Chini ya mfuniko kuna drops. It is because of the condensation of water. So the process is reversible. Ikicondense kule inadondokea tena ndani kwenye water, inafanyiwa tena process ile ya evaporation. Now what you are saying ni kwamba at the beginning of evaporation process there is no vapor to condense, and thus the rate of evaporation of a liquid is greater than the rate of condensation of vapor liquid at the initial stage of evaporation. Kwa evaporation inapoanza tunakuwa tuna nini? Evaporation kubwa. Kwa sababu gani? Hakuna vapor kule juu ambayo inaweza ka condense. Kwa the rate of evaporation tunapokuwa tunaanza inakuwa ni kubwa. These points are very important to remember them tunapo discuss concept ya nini? Ya saturation. Lakini more vapor above the surface of the liquid means more vapor pressure. at the initial stage of evaporation tend to increase. Kwa hiyo maana tunapokuwa tunazidi kuongeza vapor, tunakuwa tuna increase nini? Vapor pressure. The process of evaporation will increase until the rate of evaporation of the liquid is equal to the rate of condensation of vapor. Rate of evaporation is equal to the rate of condensation. At this point of physical process, liquid kuchange kwenda vapor is equal to vapor kuchange kwenda kwenye liquid is said to be at equilibrium. So the physical equilibrium of liquid kwenda kwenye vapor na vapor kwenda kwenye liquid inakuwa reached. So at this point nini tunakisema ni kwamba at this point of equilibrium the pressure of vapor is said to be saturated vapor pressure. Saturated vapor pressure au kwa jina jingine ni equilibrium vapor pressure. So what we explained in evaporation is like this. When we are heating this liquid, particles of the liquid they tend to evaporate to above. If the container is not closed, it means the particles will escape, and there will be no accumulation of the particles, and hence we can't reach the saturated vapor pressure in an open container. But if the container is closed, then the particles will escape to above, but later these particles they will accumulate in this space, and some of them they will condense on the lid, and then after condensation, if the rate of evaporation has been balanced with the rate of condensation of the liquids, that means we have reached a saturation point, and we call it the vapor pressure now of the liquid here. When the rate of evaporation is equal to the rate of condensation, that means the vapor pressure will remain constant. Will not increase, will not decrease, and we call it the rate. We call it the saturated vapor pressure. Saturated vapor pressure. So here is just the vapor pressure generated. The container is open, but here the vapor pressure it is closed. So by definition, saturated vapor pressure is the pressure to which vapor and its liquid are in dynamic equilibrium, and the pressure, your definition is very important kwa sababu wanauliza, and the pressure is equal to the atmospheric pressure, or saturated vapor pressure is the pressure of vapor in equilibrium with excess liquid at a given temperature. In equilibrium with excess liquid at a utachagua either useme the pressure of vapor in equilibrium with excess liquid at a given temperature, or with the pressure in which liquid is in equilibrium with its vapor component, and the pressure is equal to the atmospheric pressure. But this is the best. Kwa sababu gani? Tunapokuwa tuna saturated vapor pressure, lazima kwenye hii container yetu tunayoiona hapa, kwenye hii container, ili iwe saturated vapor pressure, lazima pressure hii hapa iwe sawa sana nani? Atmospheric. Yani pressure huku nje sana ya huku ndani. Ndio maana unatakiwa uelewe kitu kwamba tunafunika. Kwa nini huwa tunafunika vitu? Kwa nini tunafunika vitu? Tunafunika vitu ili vichemke haraka. Lakini kwa nini kichemke haraka? Yani nini kinachofanya tukifunika kichemke haraka? It is because of the increase in the vapor pressure. Tuki-increase hii vapor pressure ikafika saturation ikawa sawa na atmospheric, hii liquid inachemka kwa haraka sana. Lakini kama tusipo increase vapor pressure hapa ikawa sawa na atmospheric, tutakachokifanya ni kwamba pressure hapa itakuwa inapungua, kwa sababu molecules hapa zitakuwa zina escape. Ziki escape, pressure hapa itakuwa ndogo. So pressure huko itakuwa inaonekana kama kubwa kuliko hapa. Molecules zitakuwa zinaenda ku escape kuja hapa, zikija hapa zinaondoka nje. Na hii liquid itapata shida sana kuchemka. Kwa hiyo ndio maana lazima unajua kwamba it is very important to understand this concept. Na hii ndio concept ambayo inakuja kuleta difference kwamba ukichemsha maji eneo la mlima na ukachemsha maji eneo la bondeni, yani depending on the meters from the ocean level, zinatofautiana muda wa kuboil. It is because of this concept of vapor pressure. So what you are saying, tumesha discuss about the concept of vapor pressure na tumesha discuss about the concept of saturated vapor pressure. Naomba niishie hapa, na kwenye kipindi kinachofuata tutaendelea about the concept of vapor pressure and boiling point. Vapor pressure and boiling point. So don't forget to subscribe and to share the link for this video to your fellow students. We are continuing teaching chemistry, biology, physics and mathematics. So just stay with us. We are teaching O-level, we are teaching A-level, for free 100%. If you need these notes, you may contact me and you may join my Telegram group for more discussions, and for clarification you may comment or you may text me in my numbers there in description below. Thank you everybody. Don't forget to subscribe my channel and to share the link of this video. Let me wish you nice studies.